Okay, so in this video here, what we're going to start doing is we're going to go through our random sampling methods. Okay, so I suggest you have a grid and draw something just like this. The part that students often neglect is the how to carry out. Okay, so we want to make sure we're not dropping any marks on this one here. So a random sample, let's first of all talk about what that means. So if you think about this word, you'll probably get close to it, but it's nice to have an exact idea. And when you think about it really, when we're saying it's random, this is the key line. So it means that each sampling unit has an equal chance of being chosen. And this is going to avoid any bias. So random sampling can encompass three methods that we're interested in. And we're going to first start with simple random sampling. Okay, so simple random sampling is the one that you've probably come across before. This is the one where we're going to roughly sort of list all of our sampling frame. So that might be sort of numbering all of our people, for example, or these might be, say, telephone numbers in a phone book. So this might be person A. Yeah, let's say this will be person A, person B, person C. Okay, don't underestimate saying this. You do need to say this. And then it might be using some sort of random number generator. So we can use some random number, and you can do this on a calculator, or you can use the random numbers in the formula booklet. This is sometimes called doing a lottery. Okay, so we're going to do this, and we're going to pick the people who the number corresponds to. So if it's 3, we're going to pick this person here. Finally, what else should we say? We should say that there are going to be no repeats. Okay, so if we get the same number again, we're going to ignore that person. Okay, and we're going to keep going until we've got the number that we need. So every person has an equal chance of being selected. So they have an identifying number. A random number generator is used. And as I've said, you can add a bit more to it saying if there's a repeat, you ignore that person. You keep going until you have the value that you're looking for. So advantages of this, well, this is, of course, it's a sample. So first of all, this is quick, this is easy. It's random, so we can say that this is bias free. Again, there you go. We've got to say each number has a known equal chance of being selected. So this is a very sort of transparent method to use, and perhaps that's why you might have seen it already. Problems. There are some problems. The main one is one that you're probably not going to have thought of before. So this sampling frame, is often something that you don't know. Okay, if you have the context of, say, like a school, you know who all your people are because you could put all your registers together. But sometimes you don't know exactly how big your population is. So problem is you need a sampling frame. Okay, let me give you an example. So if we talk about like a supermarket like Tesco, and let's say you want to talk to the shoppers, well, if your population is all the people in Tesco, you don't know who they are, and they're going to keep changing all the time. Where are you going to get the sampling frame from? It's not really going to work. Okay, you need a very controlled environment, or you need some facts before, don't you, for the sampling frame? So this is a good weakness to pick up on. Also, if the population is really, really very large, this process is going to take quite a long time. You're going to go one by one finding these numbers or matching them up. Okay, it's not necessarily going to be that quick when the population is large. There's 64 girls, 56 boys in the school. Explain briefly how you could take a sample of 15. So I'd encourage you just to pause the video and have a quick think about this. And here we go. We've got the allocating a number beforehand. We've got the use of the random numbers and selecting the different numbers. So this is about perhaps sort of ignoring the repeats. And this one here is just sort of making it really, really explicit that, if the number 4 comes up, then the pupil that corresponds to number 4 becomes the person in the sample. So what you would find from this sort of old spec question is if you're vague and if you don't write enough, you could perhaps drop some marks there. So there's some key points we need to mention, okay, and we need to make sure we're answering in context. We're spending a bit of time on our questions for stats without writing a whole paragraph. that is one of the challenges that you face. We're going to do systematic next. So systematic, bit of a clue for what you're going to do. You're going to come up with a system. You're going to come up with a rule. You're going to come up with a way of doing this. So this one here is going to work really, really well when you've got very, very large numbers of data, perhaps maybe on like a spreadsheet or some on a computer database or something. So to warm up with, I want you to imagine, say, you've got 1,000 names on a list and you wanted to pick 100. Okay, so how could you go about doing this? Well, it doesn't take too much work there to see that you want 1 in 10 of the population for your sample. So one way you could do this is you could number everyone the same as before, and for 1 to 100, you could randomly, again using a generator, you could pick someone. So let's pretend we do that and you got number 56. So that's the first person in your sample. So what you can now do is you could pick 156 and 256 and 356 and so on and so on and so on. And if you did this, you know you get the right number. You've been random because before you started all of this, everybody in the population had an equal chance of being picked. But it's just now you go up in a set amount each time, okay? And that amount came from looking at the ratio of the population to the sample. So required elements are chosen at regular intervals. So our interval here was 100. The population over the sample size, okay, that will give you an idea of what you need to do. So, sorry, hang on a second. What did I say in this one here? Let's backtrack a second. Sorry, I said 1,000. Let's change that a little bit. What I did there would be useful if I wanted 10 people. Apologies for that one there. So if I wanted 10 people, that would be splitting up into hundreds, wouldn't it? Okay. If I wanted to do 100 from 1,000, my intervals would need to be sort of, much smaller. I'd need to think of it like this. Okay. So there we go. Just double check your answer. You catch anything like that. Okay. So what I meant there is if I wanted to pick, what was that? If I wanted to pick 10 people, I'd be working in hundreds in this case. So we're starting at a random number between 1 and k, and this depends in the sort of the subgroups that you're breaking this up into. Advantages with this. So this is simple and quick, and you could sort of do a little bit of trickery on a computer, and you could do this very, very quickly. So large samples, large populations is very good for indeed, and still relatively simple and quick. How does it fall down? Well, again, we've got that sampling frame problem. So we need this list, don't we, in the first place to do this. And we need to make sure that what we're saying here, that it can introduce bias if it's not random. So we need to make sure, for example, that the initial number that we pick in the interval, I would say, would be random. Otherwise, we're introducing a case of bias. That might be one problem. Generally, the easiest one to talk about is the sampling frame on these random samples at the start. So just pause the video, give this one a quick read underneath, and have a think about how you would answer this one here. And it's 50,000 to 100. So if you want 100 from 50,000, 500 is the number that you want to come up with there. Okay. So I suggest most of you would probably talk about numbering, or people are numbered 1 to 500. You randomly select this number. So this is kind of like the previous method, this one. And then it's adding 500. So if we pick 73, the next person will be 573 and 1,073 and so on and so on. That should give you your 100 names that you're looking for. Okay, and then we're on to our final random sampling method. So this is called stratified sampling. Strata, we talked about earlier, meant groups. So this is sort of like sampling when you've got groups. Here you can see the blue, the orange, the green, the red to represent our different sort of people. Blue, there's slightly more, so we might want slightly more of them. Red, there's not so many, so we might want less of them. So stratified sampling is our way forward with this. Okay. So how are we going to go about doing this? I'm going to reveal and just talk you through to start with. So the first thing is you would actually need to know what your groups are, okay? Because if we don't know this one here, then, well, we can't sort of fairly try and represent the groups here. So this is going to be our first problem. So if we take our sample size and we look at our population size and we do this sort of as a ratio together, we're able to find out how many we should pick from each. So if I just very quickly look here, it looks like there's 5 there and 5 there. So it looks like this is about a population of 50, say, yeah? Looking at this amount here, I need to get that this is sort of, 4/10, 2/10, 3/10, and 1/10. So out of these 50, what I'm going to do is I'm going to make sure that these proportions, okay, the proportions of the population are also used on the sample. Okay, so let's say we want to do our 50 to 5. Okay, let's not do 5, that's not a nice number, but let's do 10. 4/10 means I want 1, 2, 3, 4. I want 4 people. 2/10 means I want 1, 2, and so on and so on. And this is going to round to give you this 10 here. So I get a bit more input from the blue, less from the red. This is meant to be the strength, is that it's more representative. There's lots of ways of writing this. I'm not going to stick to a hard, fast rule. I'm just going to encourage you to think about the original ratios need to be reflected in the in the samples ratios. That's the way to think about it. Okay. What do you do when you know that you want 4 people, say, in this one here? Well, you just do again a simple random sample. Okay. So it's 2 techniques in one, really. It's working out how many people, and then to get those people itself, you have to revisit that simple random sampling. So this is good at representing different population structures. That means sort of like the different groups that you can see, and proportional representation, or it is representative. It guarantees it's going to be representative. So that's really, really good. You force for that to happen. Problems, however, so there's this extra step at the beginning, isn't there? Which is you have to identify the strata, and then inside the strata, you had to do the random sample. So an easy disadvantage to talk about is that it has the same disadvantages, which were on 2 slides back, about random sampling. Okay, so those are your 3 cases. You have simple random sampling, you've got systematic, and finally you've got stratified. A quick question on the board, so pause this one and have a go. It's unlikely really to be 7 marks. Pause it and we'll have a quick talk about it. So it says the school has 15 classes in the sixth form. In each there's 30. In the sixth form there are 150 students, equal number, lots and lots and lots of information. So what you need to be doing with all this stuff here is you need to be working out like what the original proportions of the school are. Equal numbers of boys and girls. Okay, so if equal numbers of boys and girls, that's going to mean that your strata of boys and girls, for example, will be the same. The head teacher wants to take a stratified sample of 40. So we want to think about the strata. We've got sixth form and we've got gender. Okay, when you do all of the working out, you should get that there's 600 in the school. Okay, so you've got your 15 classes of 30, you've got your 150 there from the sixth form. Okay, now the calculations, don't be too bothered by the calculations because there's lots of ways of writing it. So it's not one method of working out that's correct. But let's just talk through what they're doing, okay? So they're saying in this one here, why they're doing 30. So they're doing 30 because 30 is in the class. So this is telling you like a class to the population. That's what they're doing. Why are they timesing it by 40? Times it by 40 because that's the desired sample size. So this is one way of doing it. You're saying like how much of the whole school does each class have? So a 20th of 40. That's going to give you that number for your 2 that you want. Okay? This bit is only about the classes. It's not about the sixth form. So over here, they put the sixth form in. So they put 150 out of, again, the whole population, so the share of the population, and then we just apply that to the desired sample size. It gives us 10. So we've got, what have we got? We've got 2 from each of these 15. So we've got a 30 there, and then we've got a 10 there. Okay. We also say in here that we had equal numbers of boys and girls. So you could be really, really specific. You can say, you know, 1 boy, 1 girl from each class lower down in the school, and then you can say 5 boys, 5 girls from the sixth form. The process is we need to talk about labeling, okay? We need to talk about our random numbers, okay? And so on and so on. And the cherry on top would be talking about if you had any repeat numbers, what you would do with them. So there you go. There's a surprising amount that you can be asked about that. But stratified, the idea is population, composition should be shown in the sample. And as I said, many different ways you can show that in your calculation. So there you go. You've got to the end of 1B, which is about your random sampling methods.